Good. Okay, welcome everyone to OSA Friday, June 25th. Fairly on top of things this week, so we've got a decent agenda and action items. So hopefully we'll be reasonably fast today. So last time we had a good discussion about the most recent potency data. Those data are in that issue, number 76. They need to go on the wiki, unfortunately, so that's got to somehow be pasted over there. And obviously the data have to go in the master list as well, in advance of our, assembling the paper and so on. We had a good discussion about things, and I guess, there were no hugely surprising conclusions, maybe other than the Ed series of benzimidazoles were all inactive, and so we don't need to be pursued much anymore. But the other compounds that are currently being made all seem to make a lot of sense to me. I updated the synthetic targets general scheme that Dana has previously made back in March, just to highlight that I think Giada's about to tell us that she's made progress here. Flavio is on this homology series. The enamine amides have been purchased. And the things I wasn't able to update was the Northeastern University targets. And Dana, you mentioned last time a couple of things, and maybe you could just update this when you got a second to show, the current list of targets. I guess, for the coming couple of weeks kind of thing. On the Northeastern side, we spoke last time about things that were being alkylated here. I guess I just wanted to make sure that we were up to date with that, because I think that I think the R groups here we saw were going to be sort of tert-butyl and stuff like that, and it would be really good if that team could update this.
Also, I don't know if I tagged you in this, but Lori was talking to me yesterday about she has some compounds left over from another project that are similar in structure and could possibly, how we basically developed a rule: don't put anything on a bicyclic core. There's a bunch of examples of that, so it could finalize that SAR rule.
Yeah.
That would be issue 78, one down.
Yeah. I just wanted to cover the synthetic chemistry targets just for a second, just to ask people if they could update whether I'm up to date here, because this again, Flavio was talking about the homology series recently, and I just want to make sure we're up to date in terms of the targets. That's all. So if people did have a second just to update that would be really helpful.
Yeah, so from the Northeastern side of things, and Bruno, I don't know if you want to talk about it. I'm happy to. So
I could talk about it if you want.
Perfect. Go for it.
Yeah, so essentially, we're trying to switch the route because so far the alkylation has been either unsuccessful due to the fact that the moiety that we're working with is really sterically hindered. Or the reaction, does proceed when we do it with regular alkylating agent and cesium carbonate. But the problem is that we're not able to purify them from the byproducts properly, because the byproduct and the product itself, they coelute at the same retention time. So that is our main problem right now. And we're trying to solve it by looking at different strategies. So for instance, right now we're trying to see if we can just alkylate the amine. So for example, using 4-fluoroaniline, and we do reductive amination, and we see if we can attach that alkyl group that we want, and then we just couple it to the core via Buchwald reaction. So that's what we're currently testing. I could try to see if I have, like in my notes, I didn't actually create a presentation for this.
That's all right. But, that's fine. It's a useful update to know. I mean, if you had a chance to
the idea would be to prefabricate the alkyl aryl substituent and then take that new amine and then couple that to the rest of the molecule.
Exactly, precisely. So we would use, we would just have I don't know the name of the heterocycle. It's like imidazole. you know that part right there with the pyridine. So the lower part. So
the imidazopyridine. Is that what you're talking
exactly
about?
So what we would do is we would take that with the attached pyridine already,
Yeah,
and we would brominate it. That's what we're trying to see right now. So we brominate it. If we use MBS, it should selectively target that carbon where the amine is at right now.
great.
And then we're trying to see if we couple it through a Buchwald reaction to see if that would yield, some substantial products, and hopefully we wouldn't have to deal with the coelution that we're having right now, because that's a huge issue. We've been able to synthesize the molecules, we're just not able to separate them.
I wonder if change the go from an alkyl halide to something, a bigger group like a mesylate or something.
No, I think it's a good approach because it's more convergent. So you're going to be able to switch out the alcohol a little bit more easily and attach that on in the same way to each target. That's good.
Yeah. Could you repeat the suggestion with the mesylate? How?
I guess what you're co-eluting, right, would probably be like an iodine salt, right?
Yeah.
So mesylate's a bigger.
Sorry, Anthony. It's when they're doing the alkylation reaction, they're getting bis and tris alkylated.
Oh.
Yeah, you get like 3 different basic amines in there, so we get literally, yeah.
So I think in short, we're still trying to troubleshoot the root. I think, Matt, to answer your question, the alkyl group that we're planning to use is that isobutyl group, which is the one that we talked about as being the most active. And so all of these will have that. Right. Some of the chemistry that you would have seen previously with the T-butyl, that was while Bruno and Jyoti were trying to troubleshoot again to just, get a feel for the chemistry while with the reagents that we had on hand.
Right.
But the isobutyl halide has come in now. So I would imagine that we're kind of focused more on that now.
All right, perfect.
Oh.
Thanks, Bruno.
All right, no worries.
Great. If you have a chem drawer or something, or a picture of that route, if you wanted to drag it onto the issue here, that would be really awesome, just to keep us updated. Or you can download this chem drawer and edit it.
I'll work with the NU team together.
Sure.
Great. All right, fantastic. That's great.
Thank
you. Giada, are you on the call? Did you want to say something about what you've been doing this week on this chemistry? Because
yeah. If you want, I can share the screen.
Oh, okay. All right. Let me do that.
Screen. I prepare just one slide of that.
Oh, that's fine.
Can you see that?
In a second.
No.
Normally, this is the moment where it pops up. Yeah, there it is.
Can you see the slide now?
Yep.
Okay. So what I tried to do this week was, after a couple of steps, I synthesized this, as I told you last time. Then I did a Suzuki reaction for obtaining this score, and then I did a Buchwald amination for changing this northwest substituent, and so I'm still doing this reaction, and if this work, I got the first molecule, and then hopefully I will have enough amount of this product to produce other molecules. Yeah, like with different northwest substituents.
Really good. All right. Fantastic. And then the target amines are the ones that I showed, I think. Still,
Yeah.
right? So these ones.
Yeah, exactly.
All right. Great, wonderful.
Thanks.
Yep. All right. Any other comments on synthetic chemistry anyone wants to make? Just want to make sure we're up to date.
I guess just that I'm also planning on alkylating some of these products up at the top, and I can post the updated schemes after the meeting.
Okay, awesome.
Yeah.
Yeah, I posted the files if people want to, keep on editing them. That's fine.
Do we now want to proceed into the discussion me and Lori had about some compounds she has?
All right, so these are existing compounds,
Yes.
which is very exciting. So yeah, let me just bring that up here.
Yeah, so
All
these are compounds that Quillon actually made, and Quillon has snuck into the meeting. So
Hi.
Quillon's actually a postdoc in the group.
Hello.
in Houston.
How are you?
Hi,
Also
thanks for
Australian.
coming.
Yeah, we're slowly taking over the Palastri group.
Yeah. Okay. I detect an Australian accent, do I?
Yes, you do. It's definitely stronger than mine.
Is it Australian or New Zealand? Because I hope I haven't just made that mistake publicly.
No, definitely Australian.
Fine, thank you. Goodness, that's close.
Okay, so Quillon actually made these compounds in support of our research efforts for leash. And really what we're thinking about is whether we send any or all of these. My inclination is to send them all. You'll note that there are a couple of compounds with methoxys on the core.
Yeah.
But we've talked about this before, where we've only tested a couple of them, and they've been tarnished by poor outcomes. But still wonder if we can kind of use this set to put the argument to bed.
Well, I don't know. Have we tested halides on the core? Looking at 121 up there. That could be interesting.
Yeah, so we haven't actually tested the halides, but it's more the methoxys that, it's whether we have an interest in testing those.
Didn't our last compound eval find out that putting a methoxy on the pyridine was okay, not on the bicyclic?
Yeah, we have a couple of data points with the methoxy on the pyridine, and I think Matt actually posted something this morning about that. There was a comparison image that I saw.
Me, did I?
I think this is worth sending all of them just to put this point finally and get a SAR rule out of it. What do you all think?
Nothing wrong with testing a theory again. Sure. I mean, if you have them and you're willing to send them, then that's absolutely great. Really great.
Yeah, there's one, I think it's 139 that I actually may not have enough to send, but everything else I'm able to package up and send next week if you'd like them.
139 looks like it has one on the bottom segment. I mean, that's not that big of a loss, I don't think. 136, 139.
I noticed one of these has got a deuteromethyl. Was that made for metabolism reasons or something?
Yeah, it was just to test a theory to see whether or not we could do isotopic labeling as a way to slow down the metabolism. Obviously, when you use the N-methyl, it increases the metabolism for these.
Yeah, it could be interesting too to see what it does on potency. Kinetic isotope effect, because we do have a compound very similar to that, I believe.
That's very, very interesting set. I think that would be very useful. Yeah, I mean, look, if you're willing, that's fantastic. We can certainly get those evaluated. Yeah, great. All right.
We'll get them shipped out.
That's awesome. Okay. Let me just bring up there. So yeah, I didn't include that in the issue, but I will add that in. So there was another point that came up last time of the benzimidazoles going into the DNDi assay. Now, I'm assuming this is the potency assay, and a question of whether or not we still want to do that. I'm afraid I lost the thread here, because we obviously saw no activity from these compounds against MRSA, but there was some suggestion that we might want to send these off for a DNDi assay. Is that because they resemble something that you were interested in, Laurie? I forget why this came up.
I equally forget why this came up.
Okay. Because it's these guys. These guys. I don't know why we were specifically thinking about sending it off.
Oh yeah, so go on, Dana.
Oh no, go ahead. That's fine.
So Quillon might be the better one to actually speak to this, because he's kind of been looking at all of the SO2 data for this series. That's our nomenclature. Has been looking at all the data for this series in terms of leishman Chagas. And we were actually interested in whether they might have some leishman Chagas activity. We have some compounds where we've actually removed that exocyclic NH. I understand it's a different scaffold, the nitrogen's now moved across and everything, but it might actually be easier, or it might be worthwhile and interesting to get them tested at the DNDi.
I presume there's a double bond missing in 989 and 990. Should be a benzene ring.
Yeah. Yeah. Little fix. Yes. So
I mean, I think you should just test them wherever you can. If you've got the compounds, why not?
Yes.
Yeah. Let's do a mutual exchange of.
Yeah, very happy to, right? Ed, I'm
Yeah.
assuming you've got compounds to spare.
Yeah, I've got enough of all of them.
Okay. Great. All right. So maybe offline, fix up how much and where to go. Sounds good. That'd be great. Okay. Good stuff. And then, so this rather brief thing about the DNDi assay that we were running on other compounds. Is that the data set that you sent during the week, Laurie? Oh, am I getting cross wires here? Because I think you sent us through.
What?
You sent us through some ADME data.
Oh, that's not DNDi. That's from AstraZeneca.
Okay, fine. So so we are still waiting for something else from the DNDi assay.
Yes. So the DNDi, there was a bit of a backlog at AstraZeneca. The DNDi assay was, the leash assay itself usually takes about 6 weeks to give us data, but I will double check what the status is on these compounds. Sometimes I have to actually pull it directly from DNDi's database. So I will do that. I'll check today.
Okay, that's great. I just wanted to make sure I wasn't, so I did get a crosswire, which is fine. That is from that. So that's a separate thing. So we just need to digest the data and then present them, or we can talk about some other times we've correlated the numbers with structures, because that's going to be really important for us.
I've put the ChemDraw together. I just wanted to get the data also in the spreadsheet, and I'll post a new issue about that. Great.
Okay, fine. No worries at all. I think it's going to be important to digest that properly, so we can do that next time. The cytotox data is also coming through. So Alex has been working hard on that. She is generally seeing the same kind of toxicity she saw before, but she hasn't finished yet. And I think that she's offering to come next time and talk about that. Dana and I are going to chat about that with her during the week. So I think we'll have something next time for that, which is good. On the synthetic chemistry side, we just had the updates. I think Flavio is not with us today, which is fine. But he gave an update last time that he was pursuing the homology series with XOCH2 linker, just heard from Giada, and Dana's doing the one parts. And we just heard about the NE stuff. Commercial amides have been ordered. On the metabolite from Haifa, the characterization data, Ed, did you post the data somewhere already?
Yeah, it should all be uploaded.
Okay, somewhere on GitHub, is that?
Yeah.
Okay, fantastic. So it's ready to go into the paper. We've got everything there. All right, fantastic. And is there, I didn't check, but is there a note on the wiki somewhere so that we can get rid of this thing here and we just don't lose anything?
I can add it, yeah.
Okay, thank. I mean, just the fact that we got the structure and it's the same structure as the one that was predicted, but we have data for it.
Yeah,
great. Okay. And then I reached out again just today to Lee Graves because we didn't get a reply to him, but I've invited him to the next meeting to see if he can come along and just double check with us about what's needed for the mechanism of action experiments. I'm going to shut up in a second, but there was one other thing I just wanted to mention, which is this thing that I've been working on with Mike Robbins, this planetary forged Twitter bot thing. So the idea being that you have a robot that tweets out pictures of molecules for people to see, and then if you're scrolling through your Twitter feed and you see a molecule that looks like something you're working on, you can get in touch with someone to talk about the molecule and maybe put people in touch. So the idea is to have a not a wanted poster, but yeah. So actually, I can just bring it up completely. So there's a little Twitter bot which is looking at the moment at a spreadsheet, which is actually the OSM spreadsheet, the master list, and it randomly every day just picks out a row, and it takes the string and it renders the structure, and it tweets out the structure as a picture and then with the strings. And the idea is that I was hoping to get an example of it, but the idea is, you see the structure, you think, oh, that's interesting. And so on the tweet, you have to have a link to where the viewer of the tweet can see more information, right? So the source, back to the source. And so for the Twitter bot to do that, it needs the strings to render the structure and to paste them in there. But it also needs a URL so it can paste that into the tweet as well. So that the viewer of the tweet can then click on the URL and be taken to a place where it is made obvious why that molecule is currently needed for a science project. So the way this would work, and this is meant to be a Twitter bot that can help any open drug discovery project, right? So anyone could then say, well, we're running a project and we've got a spreadsheet with 100 molecules here. Can you make the robot, scrape our master list? And of course, the answer is yes, because it's a robot, no problem. But for this to work, there needs to be a column of URL. So a place where it's made clear why this molecule is needed and how people can get involved with the team who need it. So for our master list, the OSA master list, we have everything we need apart from that column of this is where you go for more information. If you just had the spreadsheet, then the person would just go to the spreadsheet and they're not really any the wiser. But so ideally what you want is a URL there that actually takes them to an issue or a wiki or something that says, oh yeah, I see why this molecule is needed. I can get involved with this project. So I just wanted to raise this with people and think a little bit about how we might be able to do that. I mean, obviously inserting a column in a spreadsheet is no problem, but the URLs that we put in there, it could be quite a lot of work to put in URLs for every compound, right? Because, and some compounds are needed in multiple places. So I'm just trying to think of what is the most useful thing to give people, which doesn't involve a massive amount of work.
But Matt, if we're using the master spreadsheet, isn't that compounds that we've already made and tested, not ones that are needed?
Yeah, absolutely. So, I mean, it could, yes, absolutely. I mean, the expectation, of course, is that they're all structurally related, right? And we've always talked about putting compounds in to a spreadsheet that are being synthesized, of course. But yeah, absolutely. There's a risk that you're putting in, if your master list consists of like 100 molecules which have been made already, and then like 10 which are being made, there's a risk that you're tweeting out things that have already been made. Yeah. So you'd hope that it works because it's part of an analogous series. So if one molecule has a fluorine on it which has been made, and you're making one with a methoxy, it doesn't really matter too much the exact nature of it. It just gives people a sense of what's needed.
Yeah, in that case, maybe a link to like the issues page for the project might be good, because that's kind of the most up-to-date discussion of what our goals are and sort of what we're trying to do in like hanging threads and things.
You mean yeah. Sorry.
Then you could just use the same URL for all the series 2 molecules. So just not a specific issue, but like just the landing page of all the issues that are open.
Yeah, I mean, that would work. That or the wiki or something, but it just depends, doesn't it? I mean, yeah, the list of issues isn't bad.
So do you want this to be compounds that we want but haven't made, or just an historical list of things that have been made?
so yeah, I mean, Dana raises a good point, and you're asking the same thing. It's a good point. And the idea is to try to get people to see, the structures and think about the fact that they could get involved because they know the same chemistry. I mean, like I said, if you see one of the series 4 molecules or one of the OSA2 molecules, you don't really care about the exact substitution pattern. What's more important is that you see the kind of general structure of what's wanted.
Other projects I work on, we have a list of ideas, if you like, and compounds which are under synthesis or would be nice to have.
Yeah, that's the most useful. We don't currently classify molecules like that, right? We could by using a certain bit of the master list.
Or we could just have a separate sheet.
That makes me nervous.
Well,
no, the thing is that the sheet of compounds that are under synthesis is quite ephemeral because compounds get deleted from it and new ones get added to it. It doesn't have to be there in perpetuity.
It's another thing to update, but I know what you mean. It's just another thing.
Yeah. The other thing we could do is we set up a while ago that Google submission form for compound ideas, and that outputs as a Google sheet. So we could have it pull structures from there.
That's true.
But that's not, I mean, up to now, it's not been really heavily used, and it's not the primary place where we are putting things that we want to make.
Right. Yeah.
I just worry that, you're going to link it to a sheet with 800 molecules, most of which you've made or are no longer interested in.
No, I mean, I think that taking the viewer to the master list would be a mistake. And also linking to something where they can't immediately see why the molecule is needed would also be annoying. So we'd need to, it needs to be carefully managed. The key is to point the bot at a list of molecules that are relevant. I mean,
that
I guess that's the most important thing. It's possible to, so the simplest thing would be not the simplest thing, a simple thing would be if you had the master list of all the compounds, and then, as we suggested before, I think once or twice, you have some rows there of molecules that are needed or proposed, and there's a column where there is a 1 or a 0 or something there, which highlights that those compounds are not yet made, which is the same idea as another sheet. It's just you're keeping it in one place, and you could have the bot just pick from that. So they are the hypothetical compounds only. I'm sure that would be doable. It just does another check on one of the columns. And one of the nice things about that, of course, is that you then just have one sheet, but also, when it's made, you just remove the tag, which then allows you to search on. So you can easily search the sheet and separate out the proposed from the knowns. And then you've just got to manage whether URL. So if it goes to the issue list, I guess if it's proposed and doesn't yet exist, then sending someone to the list of issues, which will be a static URL, which you could copy throughout, would work, right? Because if it's a proposed or wanted molecule, then it's likely to appear fairly high up on the issue list. So it wouldn't take long to find it, I guess. What, Dana, the list of proposed molecules, that goes to a separate sheet at the moment, but it doesn't go to the master list, right? So it goes to a separate sheet.
Yeah, it just Google Forms gives you the responses output as a Google sheet, but it's not tied in any way to the OSA master sheet.
Yeah.
Because it's just for proposed compounds.
And the idea then is that every now and again you copy those over, right? If you wanted to. If you liked the molecule and you thought it should be made, then of course it becomes an official target and you can copy it over.
Yeah, if that's how we wanted to use the master sheet, then yes.
Right.
Because till now it's just been once a compound is made, then it gets added to the master sheet only. We're not putting proposed or hypotheticals in there.
Yeah, right. It's yeah, I mean, part of this thing is to try and attract people in to make the molecules if they're needed. And part of the idea is to get people to notice a general structure of the molecules and think, have I got anything like that in my fridge? So in some cases, in most MedChem series, it doesn't matter too much what the exact structure is. I mean, the exact substitution pattern, as I was saying.
I guess you could also take them to the compound donation page, but that might be a bit premature given that we assume that all they know is the structure.
Right. Yeah. So I mean, the low-tech solution here for OSA would be to have a column which has, just in the URL section, it just has the URL for the list of issues. And then if we wanted to refine this better, we could then start maybe including just the list of molecules that are currently targeted. So for example, in the most recent chem drawer, currently targets, and have those somehow distinguished and just select from those. I think in our experience, installing targets is something that people don't get around to. The hypotheticals of what's coming in, we don't tend to do that, just because it's another thing to manage. Chris, is in your case, is that automated? So if someone suggests a molecule, it goes in automatically into a sheet.
The big difference is that this is not an open thing. So the registering an idea is actually important for IP.
Oh, right. Okay.
So there's a big driver there.
Right. Yep. Right. Okay. Yeah. All right. It's an interesting one. I don't know how best to do that. Either to have. I mean, it feels like the registration of ideas in the compound suggestion portal, Dana, would be a good way of doing this. I mean, there's nothing to stop us internally from doing that, right? Of course, if you've got a synthetic target, you just register it by putting it into the compound suggestion page. And then you could at that moment put in a URL, of course, that's relevant to it, right? I mean, if we were going to suggest, the current synthetic targets from today, if we registered those with the URL of this issue today, then that keeps it really simple. The issue then is that you have another sheet, that's all.
Yeah. I mean, I guess final thoughts on this would be that a lot of our proposed compounds are ones that we're already in the process of making or are closely related to chemistry that we're already doing. So I don't know how much added value it is to then tweet that out and say, can someone else make this when, I'm already sort of trying to make it. But if they're just shown sort of some general structures, then that I think that might be more beneficial for someone to say, that looks familiar, I have something similar, but maybe slightly different to some things that we're already thinking about anyway.
Yeah. Like I said, it's not so much the exact molecule, it's more the similarity.
In which case, then just pulling from the master sheet as it is would work.
Right. All right. I mean, it's going to take a couple of iterations, I think. So Mike's built the robot, which is good, and he's very happy to tweak it. So let's if someone in the master list could install a new column, which is URL, and then just fill that with, at the moment, the URL for the list of issues. Let's start with that.
I'm happy to do that. I have one more thought, which maybe is for people to think about later, but is it worth having it pull inactives, or can we filter it so that it pulls actives only? I don't know that we'd necessarily be interested in something that's similar to something that's not active.
I mean, again, the idea here is not necessarily for someone to see a molecule on a tweet and then just start making it. The idea is that they would see the molecule, quickly understand what the project is that wants the molecule, and then reach out. I think we don't need to list targets so specifically, because as you said, at the moment, all the targets have people assigned to them. So I think it's more about connecting people rather than connecting a person with a molecule, if you see what I mean.
Yeah.
But,
Okay, cool. That's fine.
Yeah.
Sorry, with that in mind, then, would it actually just be better to create a small SAR summary in like a picture form and tweet that out there and be like, if you've got stuff that looks kind of like this and, maybe does or doesn't answer some of our pending SAR questions, let us know, rather than tweeting a specific molecule and having to go through all of this. I can understand why you want to do that, but
I'm
to
trying to
achieve
think
the same goal.
Well, I'm trying to. I've got my eye on the scale up here, which is try to encourage other open projects to get involved here and allow them to also tweet out structures of molecules that they're interested in. So in
that case, wouldn't it be better if it was from a separate spreadsheet, which they then could add to via an equivalent to the compound submission thing? Basically, they can add compounds to it. It gets added to a spreadsheet and then automatically tweeted out.
it would be. I'd rather that they just already had a sheet, right? And we just take that URL of their sheet, and then the bot knows to look at it.
They're going to have to modify their sheet though as well, aren't they?
Well, just with the same heading. So they have to have the strict. All that matters is the title at the top of the column, because the bot sees that. So they would just have to have the same. I think it's the three things. It's like smiles, inchy, or whatever it is, and then URL. And if they have that, then the bot can understand it, and we can point the bot at it. So it's not much work for them.
If they have the spreadsheet.
If they have the spreadsheet, yes, that's right. So they have to just give us where that is.
But if they use the compound submission, they don't have to do anything other than submit a compound.
Yeah, sure, that's true. But yeah, that's true. Because I'm just trying to encourage people to, be independent, to have their own thing without any extra work, other than putting in a column for URL and allowing the bot to make use of it. So it's more distributed. Pointing people at an SAR diagram or an information about the series is going to be very important. And we have that on the wiki, right? We have all the SAR listed. So that's another place where people could be pointed to for sure. Or they're just taken to the homepage for the series on GitHub, so the very first page of OSA2. And then we make sure that if people arrive at that page, it's made clear that the SAR is here. If you want to talk to us, we are with these people, and this is how you can get involved. So I'm trying to think of the best way of bringing people to us that way. A structure that is representative, taken from a sheet, taking that person to a page where they would be able to reach out to us if they can help. That's the aim. So the issue list is a good one because it's kind of more up to date, but ultimately you want to make sure that when they come, they can see, or how do I reach out to someone here? Who is this project? That could be a pinned issue. So maybe that's not such an issue. Let's take them to the list of issues. We can pin an issue saying, get in touch with us or something. That's a way of doing it. I remember this from way back. We were working on some molecules in OSM Series 3 that were almost identical to some molecules being made by the Structural Genomics Consortium. And I just happened to be browsing, and there they were. And I thought, I didn't even know this existed. And so you reach out and you share molecules. That's really what it is. It's a prototype version of the Cinder robot that we proposed years ago. So we're trying to get people in touch with each other, but using Twitter. And relying on the fact that pattern recognition by humans is actually really quite powerful. Particularly, chemists looking at structures. We're really fast at noticing things that were familiar to us. But this is iterative. So, if we get things wrong, it doesn't work, then we can change anything for sure. And you learn by doing. And Mike is an absolute wizard at this kind of stuff, and he's very happy to help, which has been amazing. So let's start with one thing, which is to try and install a column in the sheet, and then let's see how it goes. And very happy to improve it or change it. I'd also like to try and encourage another team to get involved here so that we can then use the same infrastructure to help them. But I just wanted to get this working first so that the tweets are right. The rendering of the pictures doesn't work very well on the webpage. It's really funny. And Mike knows why this is. He's a technically gifted guy. He knows why the pictures look like this. And they're apparently on phones, all the pictures look perfect. But ironically, on a web page, the pictures look like that. They're kind of cut off in an awkward way because the same algorithm doesn't work on a web page. I don't know. He explained it to me, but I don't really understand what it is. But anyway, when you look at it on a phone, the pictures come up perfectly. So you can see the whole molecule. The things you learn. Yeah, anyway, it's a fun one. So yeah, we're starting small and slow, but I think we'll build something that might be useful here. All right, so thanks, Dana, for doing that. Let's see how it goes and what happens. All right. Well, okay, that's everything I had. So that's all of it. If the Northeastern team were happy to get GitHub accounts, I can tag people here if they're happy to do that. No pressure. All right. Anyone else want to raise anything, or if we forgot anything? Yeah. All right. Okay. Great. Well, thanks very much for your time, everybody.
I just updated the meeting issue for the NEU compound shipment.
Oh, great. Thank you. Perfect.
Anyway, yeah.
Great. All right. Thanks all.
Okay. See you next week.
See you next time.